According to the National Electrical Code, there is no violation of code by tying the support arms of CAN lights to the grid when installing them. Section 410.16d of the National Electrical Code states that electrical equipment shall be securely supported and shall not be supported by the conductors. Given that ramsets and tie wire are also used from the hard ceiling to support the CAN lights, the requirement for secure support is being met. Tying the support arms to the grid serves as an additional measure, enhancing stability and providing convenience during installation. Section 408.13 of the National Electrical Code addresses the use of suspended ceilings for support, stipulating that fixture chains, cables, or the like shall not be attached to a suspended ceiling grid system. However, this requirement is not applicable because chains, cables, or similar attachments are not used to support the CAN lights. The support arms, which are an integral part of the CAN light fixtures, are being used. Therefore, no code violation is associated with tying the support arms of the CAN lights to the grid in addition to employing the traditional support method from the hard ceiling. To further elaborate on NEC section 410.16d, it is essential to understand the intent behind the requirement for secure support. The primary concern is to ensure that electrical equipment is reliably held in place, preventing it from falling or creating a safety hazard. When installing CAN lights, this means that the fixtures must be adequately supported by a robust and stable structure. The use of ramsets and tie wire from the hard ceiling is a common and accepted method for achieving this secure support. These fasteners provide a strong and direct connection to the building's structural elements, ensuring that the CAN lights are firmly anchored. Tying the support arms to the grid, in addition to the ramsets and tie wire, adds an extra layer of security. This supplementary support helps to distribute the weight of the fixture more evenly and reduces the strain on the primary support system. It also provides increased stability, which can be particularly beneficial in areas prone to vibrations or seismic activity. It is important to note that the NEC does not explicitly prohibit the use of the suspended ceiling grid as a secondary support for lighting fixtures. The code focuses on the primary means of support and requires that it be sufficient to hold the equipment securely. As long as the ramsets and tie wire provide adequate support, the additional connection to the grid is generally considered acceptable. However, it is crucial to ensure that the grid system itself is capable of handling the additional load imposed by the CAN lights. The grid must be properly installed and structurally sound to prevent it from sagging or collapsing. It is also essential to consider the weight rating of the grid system and ensure that it is not exceeded by the combined weight of the fixtures and any other equipment that may be attached to it. In cases where the grid system is not robust enough to support the additional load, alternative methods of support may be necessary. This could involve reinforcing the grid with additional supports or using independent suspension systems for the CAN lights. It is always advisable to consult with a qualified engineer or electrical inspector to determine the best approach for ensuring secure and code-compliant installation. Moving on to NEC section 408.13a, it is important to understand the specific prohibition against attaching fixture chains, cables, or the like to a suspended ceiling grid system. This restriction is primarily intended to prevent the grid from being overloaded or damaged by the weight of hanging fixtures. Chains and cables can exert significant downward force on the grid, potentially causing it to sag, distort, or even collapse. This can create a safety hazard and may also damage the ceiling system itself. The prohibition against attaching fixture chains, cables, or the like to the grid is not intended to prevent the use of the grid as a secondary support for lighting fixtures. As previously mentioned, the code allows for the grid to be used as an additional means of support, as long as the primary support system is adequate and the grid is capable of handling the additional load. However, it is crucial to avoid any direct attachment of hanging fixtures to the grid using chains, cables, or similar devices. This type of attachment can compromise the structural integrity of the grid and create a safety hazard. In the case of CAN lights, the support arms are an integral part of the fixture and are designed to distribute the weight of the fixture evenly across the grid. This is different from hanging a fixture directly from the grid using chains or cables, which can concentrate the weight in a single point. as long as the support arms are properly installed and the grid is capable of handling the additional load. There is no code violation associated with tying the support arms to the grid. It is also important to consider the type of can lights being installed. Some can lights are designed with specific mounting hardware that is intended to be used with suspended ceiling grids. This hardware may include clips, brackets, or other devices that provide a secure and reliable connection to the grid. When installing can lights with this type of hardware, it is essential to follow the manufacturer's instructions carefully. The instructions will provide guidance on the proper installation techniques and ensure that the fixtures are securely supported. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply to the installation of can lights in suspended ceilings. Some jurisdictions may have additional requirements or restrictions that must be followed. It is always advisable to consult with the local electrical inspector to determine the specific requirements that apply in your area. To summarize, when installing can lights in suspended ceilings, it is essential to ensure that the fixtures are securely supported by a robust and stable structure. The use of ramsets and tie wire from the hard ceiling is a common and accepted method for achieving this secure support. Tying the support arms to the grid, in addition to the ramsets and tie wire, adds an extra layer of security and stability. However, it is crucial to ensure that the grid system itself is capable of handling the additional load imposed by the can lights. The NEC does not explicitly prohibit the use of the suspended ceiling grid as a secondary support for lighting fixtures, as long as the primary support system is adequate and the grid is capable of handling the additional load. However, it is important to avoid any direct attachment of hanging fixtures to the grid using chains, cables, or similar devices. This type of attachment can compromise the structural integrity of the grid and create a safety hazard. Always consult with a qualified engineer or electrical inspector to determine the best approach for ensuring secure and code-compliant installation. Furthermore, best practices for installing can lights in a commercial setting, particularly in a hospital, include several important considerations beyond the basic NEC requirements. Safety should always be the top priority. Firstly, before commencing any electrical work, ensure that the power to the circuit is completely shut off and properly locked out and tapped out. This prevents accidental energization of the circuit during installation, which could lead to severe electrical shock or other injuries. Secondly, use appropriate personal protective equipment, including safety glasses, gloves, and a hard hat. These items help to protect against potential hazards such as falling debris, electrical shock, and impacts. Thirdly, inspect all tools and equipment before use to ensure that they are in good working condition. Damaged or malfunctioning tools can increase the risk of accidents and injuries. In a hospital environment, infection control is also a critical consideration. Firstly, implement dust control measures to minimize the spread of dust and debris during installation. This may involve using plastic sheeting to isolate the work area, using HEPA filters and vacuum cleaners, and regularly cleaning the work area. Secondly, clean and disinfect all tools and equipment before and after use. This helps to prevent the transmission of infectious agents. Thirdly, dispose of all waste materials properly in accordance with hospital policies and procedures. This includes properly segregating and disposing of sharps, such as used drill bits and wire cutters. Coordination with hospital staff is essential to minimize disruption to patient care. Firstly, communicate with hospital staff to coordinate work schedules and avoid interfering with patient care activities. This may involve working during off-peak hours or scheduling work in specific areas to minimize disruption. Secondly, be mindful of noise levels and avoid making excessive noise that could disturb patients. This may involve using noise-dampening materials or scheduling noisy activities during times when patients are less likely to be disturbed. Thirdly, be respectful of patient privacy and confidentiality. Avoid entering patient rooms without permission and refrain from discussing patient information with others. Proper documentation is crucial for ensuring accountability and compliance. Firstly, maintain accurate records of all work performed, including the date, time, location, and description of the work. This documentation can be used to track progress, identify potential problems, and demonstrate compliance with codes and regulations. Secondly, obtain all necessary permits and inspections before commencing work. This ensures that the installation meets all applicable requirements and that it is safe and code compliant. Thirdly, provide training to all workers on the proper installation techniques and safety procedures. This helps to ensure that everyone is aware of the potential hazards and that they are equipped to perform the work safely and effectively. In addition to these general best practices, there are also some specific considerations for installing can lights in a hospital setting. Firstly, select can lights that are specifically designed for use in healthcare facilities. These fixtures typically have features such as antimicrobial coatings and sealed housings to prevent the growth of bacteria and other microorganisms. Secondly, ensure that the can lights are properly grounded to prevent electrical shock hazards. This is particularly important in areas where patients may be in contact with conductive surfaces. Thirdly, use low voltage can lights to reduce the risk of electrical shock. Low voltage fixtures operate at a lower voltage than standard line voltage fixtures, which makes them safer to use in healthcare settings. Fourthly, install emergency lighting in accordance with applicable codes and regulations. Emergency lighting is essential for ensuring that patients and staff can safely evacuate the building in the event of a power outage or other emergency. By following these best practices, you can ensure that can lights are installed safely, effectively, and in compliance with all applicable codes and regulations in a hospital setting. It is essential to prioritize safety, infection control, and coordination with hospital staff to minimize disruption to patient care.